In this video, we'll be talking about software architectures. Now, I am by no means an expert in this area. I'm not an enterprise architect, but I do write a lot of code and I build a lot of projects. And therefore, I do have to think about from time to time how I'm going to organize my projects. So this video is not going to get you up to speed with the best of the best, obviously, but what it will do for you is kind of get you initiated into the field of software architecture, give you an idea of why it's important, and kind of some hints as to how you might go about designing an architecture. Now, this is going to be great for anyone who's a beginner software architect just getting into the field, someone like myself who maybe is not a software architect but kind of in a parallel universe where this is important but not the primary focus, and then even project managers who may be kind of overseeing this process. Now, I will say that it's not going to make you proficient in designing architectures. I'm going to show you what it is, why it's important, and some of your options, but we're not going to actually dive into designing the architecture. That said, you will see some code in this video, which you should be able to reverse engineer if you really wanted to understand how to build one of the architectures that I cover. Anyone can understand what's going on here, although I will say that since we're going to be looking at some code, it'd be helpful to be familiar with code, and you're probably not going to be watching this anyway if you don't know how, so not too worried about that. Mentioned the topics a little bit earlier. We're going to be looking at why it's important. Then I'm going to be taking you through three architectures that I believe are pretty important for anyone to understand starting out. So why do we need this in the first place? I put a quote up there on the screen. I think it's very applicable to what we're talking about here, because oftentimes we get into these moments where we have to design some sort of software, and it's really fun and engaging to try to solve a complex problem in a very complex way. It's why we build Rube Goldberg machines. It's just fun to indirectly get to a solution. Now, unfortunately, when you're building a software architecture, that's not going to help you out all that much, because solving something indirectly is just going to waste your time and make things harder for people in the future. So really the goal of building software architecture is to create a system that solves a complex problem in the most simple way and effective way possible. So designing software, as you see on the screen, is about arranging the components of the system so that the quality attributes of the system are exposed. Now, what is a quality attribute? That is the question that we need to understand and answer in this tutorial. So when we think about software architecture, I know as someone who is building the actual software, it's kind of hard to take a step back and understand what the context of the software is that we're building. So every software that you would build is going to have some sort of business case. We don't just build software for no reason. There's intrinsically going to be some sort of money-making, capitalistic reasoning behind building your software. Unless you're just some software evangelist, I guess, but most of the time you're going to have a business case for your software. Therefore, this is more of a business problem than a technical problem, and when you're defining the architecture for your system, you have to consider multiple stakeholders when you're designing it. So as you can see, everyone kind of wants something. You've got the user who wants the system to be really fast. You don't want to log into Netflix and experience, some error where the streaming is all choppy. You don't want to see that. You want it to be fast and reliable. The project manager is going to make sure that the project is delivered on budget and on time. So They're less sensitive to how the project actually is turning out, although they should be, but more concerned about the timelines and the budget. And then, of course, you've got other concerns by other stakeholders. The point I'm trying to make here is that we have to consider multiple people in this equation, multiple groups in a company when designing the software architecture. Now, obviously, it's a little bit easier if you are a single developer. Maybe you're just building a personal project. You're not really going to be focusing too much on this. But ultimately, the reason for software architecture is to, please the people who are requesting it. So the problem, though, comes when, all these people are asking for something of the system, and these things kind of are conflicting. You obviously can't build a system where everything is the best, because then what's the point of architecting in the first place? The goal would just be, let's just build the best system. So you have to pick and choose which attributes, quality attributes you're going to expose within a system, and that kind of drives which architecture you're going to choose and kind of how you're going to architect that solution. So on the screen, you can pause the video, kind of look through these. These are some of the quality attributes that you might see. But I want to go into an example just to kind of bring this thing to life. So think about Netflix or YouTube. These are both softwares that provide the service of streaming video. So Netflix and YouTube, their biggest thing is going to be delivering videos or movies to the user that do not glitch up. There's no latency issues, and you're not having to wait for buffering, as people who have been on YouTube for many years have kind of experienced in the earlier years. The point here is to have high performance. And so that would be the most important quality attribute to these types of systems. You'd also want availability and usability. You want your users to always have access to the platform, and you want it to be super easy to use. So that would be kind of how you would design that sort of architecture. Now, move over to a financial services company like JP Morgan Chase, the biggest bank in the US. This is going to require, all their architectures are going to require much different quality attributes. Now, the most important one, at least I would think, is going to be security, because if your system is insecure at one of these companies, then your clients, who are your depositors ultimately, or borrowers, are going to lose their money, or maybe they're going to just have issues accessing their money. So that is obviously the most important thing that you have to ensure at these companies. And so you would definitely want to design your system so that, number one, your system is secure, and number two, it's available, so the people can get their money whenever they need to. There are many reasons why we would want to dive into software architecture and understand it a little bit better. But particularly in the case of someone like myself, who is not necessarily in charge of architecting a solution for a large enterprise, but more so just either personal projects or small clients or even small teams. I kind of put a few bullet points here on the screen that gives you a reason why this is important. Number one, it's going to enable the quality attributes that we just talked about. So the performance, availability, scalability, interoperability, all of that stuff. It also enables communication among stakeholders. So when you architect a solution, you're basically dividing your software system into logical components that somewhat map to the organization that you're a part of. So you may have a logical separation. You'll have a front end, you'll have a back end, you'll have a database or data access area, And all of these areas are going to kind of resemble how your organization is hierarchically structured. So it kind of helps to define the boundaries. It also focuses on the assembly rather than the creation of components. We care a lot less about maybe how we're going to actually code the solution, and more so about how the different pieces that we've coded are talking to each other. And then finally, it kind of restricts your choices in a way, which ultimately leads to creativity in other areas. So if you know what your boundaries are when building a software system, you also inherently know which areas you can kind of get a little bit more creative with. So I actually find that constraint of the architecture to be a little bit more liberating in the sense that I can kind of design how I want in other areas. The last thing that I wanted to mention is the fact that the early design decisions that you make when architecting a solution is going to disproportionately impact later design decisions. I know it's very tedious and sometimes even boring to try to design the architecture behind your software system, but it is worth the due diligence that you're going to do, the research that you're going to do about the requirements that you have in front of you, and all of the other things that will eventually lead to complications down the road if you don't address them up front. So just know that the decisions early on are going to impact later decisions much more than your later decisions. Now that is not to say that you should sit there and try to get the perfect solution, because you're just not going to. You're never going to get it perfectly right the first time. And also, if you're less experienced, you're also going to be less able to see into the future. The more experience you have in the architecture field, as I'm sure many expert architects will tell you, is that the more experience you have, the further into the future you can see. Kind of goes with many topics, many areas, but just worth mentioning so that you don't find yourself in this thing of analysis paralysis. So we've covered kind of the reasoning behind doing some of the architectures that we're going to be looking at. Now let's take a moment to see what architectures are available to us. Now, per Wikipedia, which actually does a pretty good job of documenting some of the various architectures, there's quite a few here, and obviously I can't cover all of them. Some of these are quite complex, even I don't understand. That said, I'm going to be focusing in on 3 of the ones that are listed on Wikipedia. And the reason that I'm going to be focusing on the monolithic, layered, and microservices architectures is because they kind of build onto each other. So the monolithic is going to be the simplest and probably the least effective. The layered is going to be kind of building on top of that, making the monolithic architecture a little bit better. And then the microservices, as you've probably read about, it's kind of a hot industry trend, is probably the most effective of these 3, and they're all kind of progressions of each other. Now, we could certainly get into peer-to-peer architectures, but that kind of leads us on a whole nother route. These 3 architectures are going to be at the foundation of learning architecture, and if you don't understand at least the monolithic and layered architectures, you're probably not going to understand much of anything else. So the first architecture, the monolithic, is not necessarily, I would call, an architecture, because you're not really thinking about how you're arranging the components to talk to each other. You're just throwing it all into one big glob of code. So you can see that everything is bunched together, so the views, the business logic or application logic, and the data access, it's all just combined into one big monolithic application. Now, it's not all bad, because this is actually kind of how a lot of projects will start. you just start by putting it all together and then you refactor it later. So it can actually be an effective way to get something done very quickly. Now it's not going to be sufficient for huge systems, but for fairly simple applications, this could be a good start, and then you just refactor it later. So it's not entirely bad to start with the monolithic. That said, it does not go very far, and once your application grows, it's going to become very tedious to maintain. It's going to be difficult for new people to come in and assume roles within the project, so on and so forth. We're going to take a quick look at some code that I put together. So switch over to VS Code here, and I've got an example of each of these architectures. We'll first jump into the monolithic one. For those that are not familiar with what I'm looking at here, I'm basically looking at 3 Express.js applications within the Node.js framework. So you may have to kind of familiarize yourself with that, or just kind of follow along as you can. So really, this architecture has 2 main parts. So you have the app right here, app.js. This is where everything's globbed together. Then you have the views, which is really just the home page, or the basically index.html as many people would know it. So there's really just 2 parts here. And when I open it up, you'll see that I just have a bunch of code all together. So this is just one big application. There's really not that much to it. There's only one route that we can do and only one API request that we can do. But it demonstrates how a monolithic application is structured. So let's walk through this to better understand it. Here at the top, you just have your imports, not really important. These are just some setup for the application. And then here is where we start to get into what I'm talking about. So in these 3 sections right here, we are setting up the database. So this is how our application is talking to the MongoDB database, and it's all within app.js. Usually you would split that out, as we'll see in the layered application later, but here it's just all in app.js. You then have this is actually a database function too. This right here is a database call, so that kind of goes with those other sections. This one's not very important for what we're talking about. Here is our view or route, so this is kind of a router within the app.js. You'd also split that out with many applications. And then finally here at the end, you're going to get an API endpoint, which allows you to register a new user. It's really simple and not actually how you would implement this, but it just kind of goes to show that you have not only the database here, so the data access is going on up here, then you have some views, and then you have some API routes. So it's all globbed together, and you can see that if you wanted to change anything about this application, you're going to have to go into this one big file. And it's not going to be very easy for a bunch of people to work on it at the same time. Although this app is not really complex, let's just take a quick look at it. So let me run this, and it's not going to let me because I haven't started the database. So I need to come over here, set the database, then go back to my first terminal. I need to export a database user, which is going to be Zach, and then a password, which will just be 123, pretty easy. And then I can start the application. I'll visit this here at localhost 8080. And you can see that this is our monolithic application. It's showing that I'm registered and logged in just because local storage is, I kind of was working on this earlier. Let me just clear that real quick and reload. So now we have to register, so we'll say Zach at email.com and register. And now it's going to say you're registered and logged in. Very simple, not a useful application, but this is just an example of a monolithic architecture and how you might get started. All right, enough with that. Let's go back to our architecture types. The next one is going to be a layered architecture. And this is kind of an extension of the monolithic one. It's kind of how you might refactor it. So previously we saw that everything was kind of all globbed together into that app.js file. Now with a layered architecture, the idea is that you separate things out into different layers. Pretty obvious. Now, one thing to mention with this layered architecture is the concept of closed and open layers. So if a layer is closed, as we see on the right here with these little boxes, that means that that layer can only use the layer directly below it. So, for example, the presentation layer can only use the business layer, and the business layer can only use the data layer. Now we have this open layer here, which is like a shared utilities layer. It's like a library, maybe some string transformations or objects transformations, what have you. But an open layer is going to be available for any of these layers to use. So not only can the presentation and business layer use it, but the data layer can as well. Okay, enough talk. Let's go into our application again. Let me get out of the monolithic one and enter into the layered architecture. So as you can see, we've already got a little bit more structure to this. So I have a folder for the presentation layer, a folder for the business, and a folder for the data layer. Rather than trying to walk you through the code of this, I'm just going to start it and then show you kind of how it's structured here. So it actually has two parts. So you'll have a static server for the view and then a server for the Express application, which is in the business layer. So I will need to run in this first terminal node business. Well, actually I need to get into the actual folder here. So node business layer app, oh, what is it called? Oh, business layer user.js. Okay. So we'll run that. This is running on localhost 8081. And then we can jump over to another terminal. Again, we still have the database running in the background. And I can run node presentation layer. And then that's going to be server static, and that's on localhost 8080. So let me visit that because that's where the main application is going to be running. You'll see here that this is a pretty similar application to what we just saw. I can enter my email and we can load a profile, and I've already put this in the database, that's why you see stuff here. But basically this explains all the requests that are happening when I load that profile. So let me just walk you through. When I clicked that button, what actually happened was we cascaded down from the presentation layer to the business layer to the data layer and got some information back, which is displayed here on the screen. So when I typed in my email here and clicked load profile, this is basically what happened. So we started in the presentation layer at the index.html. I pressed the load profile button, and when this was submitted, you'll see that I run this method called getData from business layer. That happens to be still in the presentation layer. Here's the function right here, and the implementation is not as important as the call that we're making. So you can see that the call we're making is a GET request to this URL. Notice we're requesting from localhost 8081, which is where the server for the business layer is running. So we're going to this route, which we can hop over to the business layer and open up that file to see. So we'll scroll down. You can see here's the API route that we had just called, and within this API route, we are calling a data access layer method. So we have the user model object, and that has a method called getUserByEmail. So let's go into the data layer. So we'll go down to data layer, open that up, and we'll find that method. So here's the method right here. You can see we're running that getUserByEmail, and then within this method, we're calling an actual database call. So we're contacting the database directly through a Mongoose method called user.find1. So that's going to kind of ping the database. We get our user object back, and then that cascades up the chain into the presentation layer and ultimately displays on the screen right here. So you can see how we have actually split all of these calls out into different layers. And if I wanted to come back here and edit a different layer, you can see that I can do that without totally breaking other layers. So I might, maybe I want to come down here and add another method. So getUserById. And I can start adding a new method to my data layer, which then I can tell the team that's working on the business layer, hey, I've implemented a new method here, go ahead and use it. So this is how we can kind of start to see teams of an organization splitting out and working on the same project at the same time. So that would be the usefulness of the layered architecture. The one drawback here is we're still going to have to do a daily, weekly, or monthly release schedule. So every time, even though we're implementing this new method here in the data layer, and that doesn't totally affect everything that the other teams are doing, we're still going to need to restart the entire application to see this change go into effect. So therefore, we're going to have to maintain a release cycle. You'll see that as we go into the microservices architecture, we don't have this problem, which is why a lot of companies are migrating towards it. All right, so the last architecture that we're going to talk about is the microservices architecture. And it's kind of probably one of the most popular architectures for building web applications today. So it's very important to at least understand what it is. Now, I haven't been very impressed with a lot of the explanations that you'll get online about microservice architectures, because I feel like they either overcomplicate it or just don't explain it well enough. More, it's too abstract to actually understand. So in this example, I'll show you a sample application that implements this type of architecture. So the key here is that each of the microservices that you're implementing are going to be completely independent of each other. They're going to basically run on totally different servers, and therefore, you could have a team working on one microservice out in California and another team out on the East Coast working on another microservice for the same company. So it really segregates out the duties and allows you to collaborate on a project very easily. A perfect example of this is going to be Google. So as you log into tons of applications, you have the option to log in with Google. Now this is, I don't know exactly how it's implemented, but I would assume it's some sort of microservice where we can use this user authentication service across many, many different Google applications, and also we're using it across many external or third-party applications. So it's, it would be very tedious if every application that Google owned and ran had its own authentication scheme, because you'd be doing it hundreds of times. So what makes more sense is just designing a user authentication like microservice and then using that microservice within each of the applications. Now, the one that I have created, or the application that I have created here, is far less complex from anything that Google would have, but I think it will demonstrate pretty well what this microservices thing is all about. Again, I'm just going to start the application and then walk you through the parts of that application. So I have two microservices here. One is going to be user authentication, and then the next one is going to be a game. And both of these microservices are going to be presented to you in the what we call the public folder, which is basically, you could think of it as the presentation layer. So the presentation layer or area is going to pull these microservices together into one user experience, which is very common among this type of architecture. So let me get this started. I will first run the, actually we just need to run app.js. So that's running at localhost 8080. So here is our full application that I kind of created for this tutorial. You can see we have a register, a login, and then a game functionality. You can't tell from this screen, but this little game area is running a totally different server than this register and login user authentication area. And you'll see that within the game and user authentication, we have two different servers and totally independent applications that have their own data access layers in the data.js. So let's get those started as well. We'll come over to our first terminal and run game server. So that's going to run on localhost 8082. And then I think we have an open terminal here. We will run the user authentication on, well, let's see, I have not exported my variables, so dbuser equals Zach. So here I will run the user authentication server. That's going to be on port 8081. So in total, I have something running on port 8080, which will be the view or the presentation part of the application. That's just a static server. And then I have a server on 8081, which is the user authentication. And then on 8082, we have the game. So let's just walk through a couple requests that your users could make to this application. Let's come into the browser. The first thing that you might do is register and log in. So it says that I'm logged in. Again, this is because I have some stuff up in local storage that I need to clear out so this works correctly. So let's reload. We're not registered or logged in yet, so let me just say test@email.com and we'll enter an easy password. Okay, we're registered. We need to log in, and this is where I'm going to kind of show you how this microservice works. So we'll go with the email that we just put in and the password, and when I click login, it's going to send an API request to the user authentication microservice. So I'll press login. It says you're logged in as test email or test@email.com. But what's more important is to understand what just happened here. So we'll come down to the user authentication code and walk through everything that just happened. So the first thing is the front end, so the index.html, has a button here that should be the login button, if I'm correct. Yep, so this is the part of the presentation layer that's going to, or not, I keep saying layer, but it's really just the presentation server. We're implementing a login method, which is in script.js. So you'll see the login method right here is going to submit a post request with the form data to localhost 8081/authenticate. So if you remember, the 8081 port is going to be microservice number 1, which is the user authentication. And server.js right here is that microservice. So you come down, you can see that we have a API endpoint for register. which is going to create a user, and this is going to be utilizing the data.js file, which has implemented basically a data layer. So you can start to see how we actually have a layered architecture kind of embedded within each of the microservices. It's kind of tricky to, or not tricky, but it's a little bit conflicting to think about an architecture within an architecture, but you'll have to get comfortable with that because it happens all the time. There's tons of architectures that are kind of going to be embedded within others. It's just how the game is played. So you'll see that that's how we implemented microservice number 1. The second one is the game. So this is going to be using a totally different microservice. Let's start playing the game, and you just have to stop it up in the top. I successfully did that. Let me just play it again so that you know it's not rigged. Don't know how I got that the first time. So really what I wanted to show you here is the see your score history, because this implements microservice number 2. So when I click see your score history, you'll see that I have a win count of 1 and a loss count of 1. Coming back to our code, let me close out all of these files. You'll see that in index.html, there is a button down here that says see your score history. And when that is clicked, there's actually a click handler, I believe. Let's see. See scores. Okay, here's the click handler. So when we click on that button, it's going to implement the see scores function, which we can come up here. Here's the function we're calling, and then the route that we're going to request from, it's going to be a GET request to the localhost 8082, which is the second microservice, which is our game. So let's look for this route within that game microservice. So we'll come down to this game microservice and open up the server. And you'll come down and you'll see that we can get the scores for a particular email. So the email that's logged in is going to be the one that it's querying, and you can see that we're going to our data access layer to implement a method to make a call to the database to get that score. And then that populates back up into the user interface and displays the database information here. So I know I threw a lot at you right there, but I just wanted to introduce what a microservices architecture might look like. Now the thing about microservices architectures is they're not really that effective in a simple system like this. It's just going to require a lot more work. You're starting up multiple servers to just have this simple little user interface. But it does become very helpful as the application gets really complex and you have, multiple people working on it, and you have multiple pieces of functionality that are all embedded into a single user experience. So that is truly the value of a microservices architecture. I hope that this was a little bit enlightening, gives you a little bit better idea of what it is. There are 5 billion videos watched on YouTube every single day, and you chose this one. So thank you for watching, and congrats on making it to the end of this video. I know this stuff can get really challenging at times, but just keep chugging away, keep showing up every single day, and eventually it will start to make sense. If you could do me a quick favor, just hit that subscribe button. I think it's right about there, and throw a like on this video if you learned anything from it. Until next time, I will see you later.